Hey, Mrs. KJ here to go over 6.02 Voltaic cells. Voltaic cells produce electrical power for everyday devices. In many chemical reactions, electrons are transferred from one substance to another. This transfer often takes place when the two substances come in contact. However, if the reaction can be separated in such a way that the electrons had to flow externally through some device, then electrical energy would be produced in the form of an electrical current. Such a process is the basis of voltaic cells, which you will learn about in this lesson. Goals for this lesson: interpret a diagram of a voltaic cell, compare and contrast an anode and cathode. Voltaic cells produces electric current, flows into the cathode where it's reduced. Voltaic cells produce electrical current which flows out of the anode where it is oxidized. And a good way to remember these is this side. Notice how it's all vowels. The electrical current flows out of the anode, which is oxidized. All right, so we got our student guide, kept the beginning and the goals. Anode is a negative terminal of an electrochemical device. And remember, this is easy to remember because of the word anode. It's a negative device. So if you think of it like that, a negative. So whenever you read anode, you should read a negative. Cathode is the positive terminal of an electrochemical device. So hopefully you remember this from anions. Remember, a negative ion and cathodes are positive ions. Now we have anode, a negative terminal, and the cathode, the positive one. We have the voltaic cell, which is an electrochemical device that produces electricity from chemical reactions. Voltaic cells produce electrical power for everyday devices. Voltaic cells are also called galvanic cells, and they are electrochemical cells that convert chemical energy into electrical energy. They have these basic features. They use different metal strips as electrodes. The strips are either in the same solution or in separate solutions that are connected. So here they're in separate beakers, but notice the glass tube that's connecting them. Oxidation reduction half reactions occur at each electrode. They have separate pathways for the flow of electrons via a wire connecting the electrodes. All right, so we got our wires. And ions flow through the solution to maintain neutrality. So a voltaic cell produces electrical power from a chemical reaction. And again, I'm just going to put this whole thing in the notes, which I know is not the best way to take notes, but again, this is probably brand new, and they actually have all the different parts spelled out pretty well here. If you would prefer to rewrite it and make it shorter, please go ahead and do that in your notes. All right, the next slide says start with a spontaneous oxidation reduction reaction. So again, spontaneous means it's just going to happen on its own once you put the chemicals together. The chemical basis of a voltaic cell is a spontaneous oxidation reduction reaction. To make a voltaic cell, the oxidation reduction reaction is first separated into two half reactions, each located in a separate half cell as shown here. So we have half cell 1, which contains our copper strip, and it's in a copper sulfate solution. Beaker 2 is a zinc sulfate solution. So notice they both have sulfate in them. And then of course we have the strip of zinc. The two parts of the spontaneous redox reaction are separate and placed in individual half cells. So we call the whole thing a cell because it's split in half. We call it a half cell. So you can notice here we have our copper, and there is copper in the solution as well. And this is the sulfate. So you notice that that's the same in both beaker because they both have sulfate. It's just that this one has the zinc strip and also the zinc in solution. Electrons travel through a wire. Okay, so again we have our same half cells set up here. Now they just added a little bit more. All right. Oh, I thought maybe they would have shown the zinc. So if we could see it, we'd also see the zinc sulfate down here and the copper sulfate down here. Two half reactions occur in the zinc copper sulfate oxidation reactions. So we have our solid zinc, and it breaks down into zinc, which is aqueous, so in solution, plus 2 electrons. We have our copper, which is plus 2 in the aqueous. It's going to grab those 2 electrons and become copper solid. All right, the half reactions occur on the surface of the zinc strip and on the surface of the copper strip, respectively. Electrons flow from the zinc atom to the copper 2 ion when the metal atoms come in contact. Once the half reactions are separated, the electrons need a path, the wire, where they can flow. The resulting electron flow or electric current can do work such as powering an electric device. So here they have a voltmeter, so this would just show the fact that electricity is going through. They could put a light bulb there, they could put your MP3 player there, they could put other stuff there. And then they show the salt bridge. So if you notice, we got that sulfate going through, and we have the sodium, so it's an Na2SO4 salt bridge, and that's going through to help keep the whole thing neutral overall. So we talked about the electrons going through the wire, and this one says the ions must have a separate pathway. As the half reactions proceed, each half cell will either gain or lose ions. Other ions must move between them to balance the electrical charges. The ions move through the salt bridge, that's what we call this glass tube, okay? So the ions move through the salt bridge made of a gel called agar that is soaked in an electrolyte, usually sodium sulfate or potassium sulfate. So inside this glass tube is where they have this Na2SO4 gel, which is called agar, or it can be K2SO4, and that allows the back and forth to keep the thing neutral overall. And I did copy paste the last slide in the note, and I'm doing the same with this one. Oxidation occurs at the anode. So remember, anode is a negative, so it's the negative end where the oxidation happens. When the voltaic cell is fully assembled, the oxidation half reaction will occur at the zinc strip. Zinc will be oxidized, okay? And so we look at its charge. It went from 0 to +2, so it increased in charge, so it was oxidized. So we have our solid zinc, and it turns into zinc, which is aqueous, or floating around, plus 2 electrons. The electrons produced in the reaction will flow up the zinc strip. Okay, so here we have zinc, right? We have our pure zinc here. The zinc turns into zinc 2+, and that goes into the solution, and it has the 2 electrons. And the electrons go up, up, up the zinc because it's going to go through the wire here eventually. This zinc strip will accumulate electrons and become negatively charged. As such, this metal strip or electrode is called the anode, a negative end. Zinc 2+ ions will move into solution, SO4 minus 2 ions. Okay, so here's this coming from our salt bridge here. The sulfate ions will move from the other half cell, so from the beaker that's over here, that's obviously not shown in the picture. The sulfate ions will move from the other half cell through the salt bridge and into this half cell to balance the increase of zinc plus 2 ions. This half cell will remain electrically neutral. Okay, because you have the electrons going up, you have these positives down here. Well, the sulfate is negative, so it comes and hooks onto the zinc and helps keep it neutral. So if we look at our picture of our zinc, the sulfate's coming down, electron pairs move up the zinc strip to carry the current, zinc atoms lose 2 electrons, again they went up, and enter the solution as zinc plus 2. All right, so again, just copy paste this into the notes. If you feel like you really get this and you can kind of streamline your notes, that's great, go for it. So if oxidation happened here at the anode, what do you think is happening in the other beaker? Well, that's going to be reduction occurring at the cathode. When the voltaic cell is fully assembled, the reduction half reaction will occur at the copper strip. Copper 2 ions will be reduced. So we have copper plus 2, which is aqueous, plus the 2 electrons is going to yield solid copper. Okay, so in the beaker we have copper plus 2. It's going to turn into solid copper. And the reason it's able to do that is it's getting 2 electrons. So these 2 electrons are coming onto this Cu plus 2, and they're making copper. Now, this Cu plus 2 was part of the sulfate, and it broke apart, so that sulfate's going to go through the bridge. And remember, it was needed over, there we go, over here in this picture. Okay, so the sulfate goes through, and these electrons, remember they were going up the zinc and through the wire, and they're going to keep coming through this wire, and they're going to be coming down on the piece of copper. The electrons will combine at the strip in the reduction reaction, and the strip will become positively charged. As such, the metal strip or electrode will be called the cathode because it's positive. Cu plus 2 ions will move from the solution onto the strip. So notice how the strip is kind of starting to look like a spoon, and that's because more pieces of copper are coming onto it. Sulfate ions will leave this half cell through the salt bridge. Okay, so remember these two were connected, they split apart, and this sulfate now is going to go through the salt bridge to balance the decrease in copper plus 2 ions. This half cell will remain electrically neutral. And if you notice, although they didn't say it over here, originally in the salt bridge it was sodium sulfate, and so some of the sodium is going to come down in here, and the sulfate's going up because it's going to go over to the zinc side. The copper was in solution, it's attaching itself to the strip. The electrons are coming down, which they're showing with the blue circles here. So electron pairs move down. This piece comes together with the electrons, and it creates copper ions leave solution and combine with 2 electrons to make just plain copper. So it was copper plus 2, now it's copper 0. It has less of a charge, it was reduced. All right, so again, on the notes, I'm just kind of copy pasting stuff in. If you can make it more streamlined because you really understand this, awesome. If not, no big deal. This takes a little practice. Electric current is generated by the flow of electrons from anode to cathode. Zinc is oxidized at the anode. The electrons flow up the zinc strip and through the wire. Okay, so here's the picture. The electrons are going up through the wire. As electrons flow through the wire from the anode to the cathode, they can do work. They can power a device. They can turn on a light bulb. They can work your MP3 player. Now, the zinc plus 2 ions move into the solution, because remember they were zinc, but now they're zinc plus 2 because they lost those 2 electrons. And I'm just going to start with this paragraph again. Zinc plus 2 ions move into solution, and the sulfate ions move from the copper side. So remember the SO4 -2? They came up through the salt bridge into the zinc side of the half cell to balance the increase of the zinc plus 2, because we have our -2 sulfates and our plus 2 zincs. So they balance each other out. Copper plus 2 ions will be reduced at the cathode. The electrons will flow from the wire into the copper strip. So the electrons started at the zinc, they power the light bulb, they keep going, now they're in the copper. Copper plus 2 ions will move from solution into the strip, and the sulfate ions will leave this half cell through the salt bridge to balance the decrease in copper plus 2 ions. Both half cells will remain neutral. All right, and then the picture, of course, blown up a little bit more. So what I suggest you do, copy paste the picture, but then copy paste another one and put little squares over. So if you can fill in the blanks, you understand this. Do the same thing with the particle view. Do you know how to fill in the blanks? Good. If you don't, practice it, try it again the next day. Same thing with this paragraph. Can you fill in all the blanks? If you can't, you need to study it some more. If you can, great. If you can after looking at it right away, try again tomorrow. Make sure you still remember it. So that's a good way when we have so many paragraphs of notes to test, do I really know them or not? Again, don't just say, zinc is oxidized at the anode. Oh yeah, I knew that. No, if you can't fill in the blanks without looking at the answers first, you don't really know it. So make sure you really know it. What are the differences between the anode and the cathode? So this would be another one where I'm going to copy paste this in the notes and then cover all these up. Can you fill this out without looking at it? Make sure you really know it. Compare the properties of anodes and cathodes for voltaic cells. Usually if the difference between the activities of the anode and cathode is large, the voltaic cell will produce more electricity. So, half reactions. Anode, oxidation. Cathode, reduction. Anode, negative. The charge is negative. Cathode, positive. Metal activity, higher, more easily oxidized. For a cathode, it's a lower activity, less easily oxidized. Direction flow out of the anode, cathodes into the cathode. Another way to remember that, electrons are negative, so they have to start at the negative end. So put that in your notes, and we will, actually I'll make a video of the last minute.